Hey there, and welcome back to the Simple AI Guide, where we take the complicated world of artificial intelligence and explain it in plain English. My name is Hope. Today we are discussing something that is useful to understand. How does AI work? Not the hype, not the headlines, but the real plain English explanation of what is happening under the hood when you talk to a chatbot, get a movie recommendation, or hear about a doctor using AI to read a scan. Here is something I want you to hold on to right from the start. AI is not magic. It is not science fiction. It is not some mysterious force that only genius engineers can understand. AI works by learning patterns from large amounts of data and using those patterns to make predictions. That is the whole thing right there. The same way you learn to recognize your family dog without anyone handing you a rule book. You just saw the dog over and over until your brain figured it out. That is essentially how AI works too. Now, we are going to unpack that idea in a lot more detail today, because once you understand the pieces, a whole lot of things start to make sense. Why does ChatGPT sometimes get things wrong? Why does Netflix seem to know what you want to watch before you do? Why are doctors using AI to read medical images? It all traces back to the same core ideas we are going to walk through together. So, let's start at the beginning. AI, or artificial intelligence, is not one single thing. It is a broad category that includes lots of different technologies. But when most people talk about AI today, the kind you're seeing in the news, the kind you might be using yourself, they are talking about a specific approach called machine learning. And within machine learning, a lot of the most powerful modern AI uses something called neural networks and deep learning. Do not let those words scare you. By the end of this episode, you are going to understand what those terms mean and why they matter. Let us start with machine learning, because that is the foundation of almost everything. Machine learning simply means that instead of a programmer writing out a long list of rules, like if this, then do that, the AI learns the rules itself by looking at examples. That is it. That is the whole concept. Think about how you learned to read. Nobody sat you down and gave you a complete rulebook for the English language before you started. You were shown letters and words over and over in different contexts, and gradually your brain figured out the patterns. Machine learning works the same way, except instead of a child in a few years, we are talking about a computer program and potentially billions of examples. Here is a simple illustration. Say you want to build an AI that can tell the difference between a photo of a cat and a photo of a dog. The old-fashioned programming approach would be to try to write out every rule. Cats have pointed ears, cats tend to have whiskers, cats have a certain body proportion, and so on. But there are so many exceptions and variations that writing rules like that is basically impossible. You would never cover every case. The machine learning approach is completely different. You just show the AI thousands and thousands of photos, some labeled cat, some labeled dog, and the AI figures out the patterns on its own. After enough examples, it gets very good at telling cats and dogs apart, even in photos it has never seen before. Now, here's the key part of how that learning actually happens, because this is where it gets interesting. The AI starts by making a guess. It looks at a new photo and says, I think this is a cat. Then the system checks. Was it right? If not, the AI adjusts its internal settings. We call those settings the model's parameters or weights to do a little better next time. Then it tries again, and again, and again. Millions of times, each time getting just a little bit better. Think about learning to play piano. The first time you sit down, you hit wrong notes. Your teacher says, no, that is not right. You adjust your fingers, you try again. After thousands of practice sessions, your fingers know where to go almost automatically. AI follows the exact same pattern, just at a speed and scale that no human could ever match. Now, how does AI learn from all those examples? This is where neural networks come in, and I want to spend a good amount of time here because this is the architecture behind basically all of the most impressive AI you are hearing about today. ChatGPT, image generators, the AI that reads medical scans, all of it. A neural network is a system loosely inspired by how the human brain works. Your brain has billions of neurons, nerve cells, and they are all connected to each other. When you see something, hear something, or think something, signals travel through those connections, and patterns of activation create your thoughts and perceptions. A neural network in a computer is a digital version of that idea. It has layers of nodes, little mathematical units, all connected to each other. Information flows in at one end and comes out as a prediction at the other end. passing through all those layers in between. Let me walk you through what that looks like in practice. Imagine the AI is looking at a photo to figure out who is in it. The very first layer of the neural network picks up the most basic things, such as raw edges, dots of color, simple shapes. At this stage, the network is not making any big conclusions. It is just processing raw information. As the signal moves into the next layers, called hidden layers, the network starts combining those simple features into more complex ones. This area of pixels that have certain edges and colors might add up to the shape of a nose. That other area might look like an eye. Groups of features start to become recognizable as meaningful parts. By the time the signal reaches the final layer, the output layer, the network has put it all together. It says, based on everything I just processed, this looks like a specific person, or a cat, or a tumor on a scan, or a spam email. The more layers the network has, the more complex patterns it can recognize. This is why we call sophisticated AI systems deep learning. They use neural networks with many, many layers. Deep, as in deep stacks of processing layers. Now, here is something worth noting. When we talk about an AI recognizing a face or reading a scan or answering a question, it is very easy to start thinking of the AI as seeing or understanding the subject the way humans do. But that is not what is happening. The AI is doing pattern matching. Very sophisticated, very accurate, incredibly fast pattern matching. But pattern matching nonetheless. It does not know what a face is. It does not understand what it means for someone to be sick. It does not comprehend the words it is generating. It has found statistical patterns in enormous amounts of data, and it is applying those patterns to new inputs to produce outputs. This is a really important distinction, and we will come back to it when we talk about limitations. But for now, keep that in mind. AI is a powerful pattern matcher, not a thinker. Okay, so we have covered the basic idea of machine learning and how neural networks process information. Now let's talk about the three main types of learning that AI systems use, because they work quite differently. The first type is called supervised learning, and it is probably the most common approach for many practical AI applications. In supervised learning, every piece of training data comes with a label, a correct answer. This is a cat. This is a dog. This email is spam. This email is not spam. This patient has early signs of heart disease. This patient does not. The AI learns by comparing its predictions to those labels and adjusting until it gets things right. It is called supervised because it is like studying with a teacher or studying with flashcards. You always know what the correct answer is supposed to be, so you can check your work. Think about spam email filters. The AI was trained on thousands and thousands of emails, each one labeled by humans as either spam or not spam. Over time, it learned the patterns. Certain words, certain sender addresses, certain structures that tend to show up in spam. Now it applies that learning to every email you receive. The second type is unsupervised learning, and this one is a little different. In unsupervised learning, the AI gets data with no labels at all. No right answers, no teacher checking its work. It has to find structure and patterns in the data entirely on its own. This sounds harder, and in some ways it is, but it is also incredibly powerful because there is so much unlabeled data in the world. Most of the data that exists has never been sorted and labeled by humans. A good example of unsupervised learning is customer segmentation. An online retailer might feed the AI data about millions of customers, what they browse, what they buy, when they shop, how much they spend, and ask the AI to find groups. The AI might come back and say, here are 5 distinct types of shoppers. This group tends to buy practical household items on weekday mornings. This other group splurges on luxury items around the holidays. Nobody told the AI what groups to look for. It found those patterns itself. The third type of learning is called reinforcement learning, and this one works like training an animal. In reinforcement learning, the AI tries different actions and gets feedback in the form of rewards or penalties. Good action, you get points. Bad action, you lose points. The AI learns over time to maximize its rewards. This is how some of the most impressive AI feats have been accomplished. Remember when you heard about AI beating world champions at chess and the game of Go? That was largely reinforcement learning. The AI played millions of games against itself, getting rewarded for winning moves and penalized for losing ones, until it became unbeatable. Self-driving vehicle technology uses reinforcement learning too. The AI makes decisions about when to brake, when to change lanes, when to yield, and it gets reward signals for safe, smooth driving and penalties for risky behavior. Over billions of simulated miles, it gets very, very good. Now, in practice, modern AI systems often blend all three of these approaches. The large language models behind tools like ChatGPT were trained first on massive amounts of text using unsupervised style learning. Just find the patterns in all this text. Then they were fine-tuned using supervised learning, where humans provided labeled examples of good and bad responses. Then they were further refined using reinforcement learning with human feedback, where real people rated responses and those ratings were used to improve the system. It is a layered process, not a single technique. Let's take a step back now and talk about the ingredients that make all of this possible, because AI does not just appear out of thin air. There are three things you need. The first ingredient is data. Data is the raw material that AI learns from. Pictures, text, audio recordings, numbers, medical records, customer transactions, any kind of structured or unstructured information can potentially be training data. The more of it you have and the higher the quality, the better your AI can become. If the data is biased or incomplete or poorly collected, the AI will reflect those problems. Garbage in, garbage out, that is a phrase you will hear a lot in discussions about AI, and it is absolutely true. The second ingredient is algorithms. An algorithm is simply a set of instructions, a recipe for how to do something. In the context of AI, the algorithms define how the neural network is structured, how it processes information, how it adjusts its weights during training. Different algorithms are better suited for different tasks. The algorithm choices made by AI researchers and engineers have a huge impact on what the system can do. The third ingredient is computing power. Training a modern AI system is incredibly demanding. We are not talking about a laptop here. We are talking about server farms full of specialized chips called GPS, graphics processing units. These chips were originally designed to render video game graphics, but it turns out they are also very good at the kind of parallel math that AI training requires. Training the largest AI models today costs tens of millions of dollars just in computing resources. That is part of why AI has developed so rapidly in the last decade. The cost of computing has dropped dramatically, and the availability of data has exploded. Universities and research hospitals, like Case Western Reserve University in Cleveland, have invested heavily in this kind of computing infrastructure so that researchers can develop AI systems for medicine, science, and other applications. Now, I want to spend a few minutes on something that I think is really important to understand, and that is what AI cannot do. Because the hype around AI can sometimes make it sound like there are no limits, and that is just not true. The first and maybe most important limitation is that AI is only as good as the data it was trained on. If the training data contains biases, and almost all data does because it was collected by and about humans who have biases, the AI will reflect those biases. If the training data is incomplete or does not represent certain situations well, the AI will perform poorly in those situations. This has been a real problem in things like facial recognition systems that perform less accurately on people with certain skin tones, or medical AI systems that were not trained on diverse enough patient populations. The second limitation is that AI struggles when it encounters situations very different from what it was trained on. This is sometimes called the out-of-distribution problem. A self-driving car trained in sunny California might struggle on snow-covered roads in northern climates because it simply has not seen enough examples of that situation. AI is remarkably good within the boundaries of its training data and remarkably brittle outside of those boundaries. The third limitation is that AI lacks common sense in the way humans have it. You can reason from first principles, you can look at a brand new situation you have never encountered and apply logic to figure out what to do. AI cannot do that. It knows patterns from its training data, but it cannot reason its way through truly novel situations the way a thoughtful person can. The fourth limitation is something called the black box problem. In many complex neural networks, even the experts who built the system cannot fully explain why it made a particular decision. The AI processes information through so many layers that the path from input to output is not transparent. This is a serious concern in high-stakes applications like medicine or criminal justice, where we need to be able to explain and justify decisions. A lot of research is going into making AI more explainable. but it remains a significant challenge. And the fifth limitation, worth saying clearly, is that AI is not conscious, is not sentient, and does not have emotions or genuine understanding. Despite the name artificial intelligence, current AI systems are not intelligent in the way humans are. They are tools, incredibly powerful, useful, sometimes surprising tools, but tools. A chatbot that writes a beautiful poem has not experienced anything. An AI that diagnoses a disease does not understand what it means to be sick. These systems are doing sophisticated pattern matching, not thinking. Understanding these limitations is not about being negative about AI. It is about being realistic, which is what you need to be in order to use AI well and to make good decisions about when to trust it and when to question it. Now, with all of that context, let me tell you about some of the areas where AI really is making an extraordinary difference. In healthcare, AI is doing things that were science fiction just a decade ago. Researchers and doctors are using AI to analyze medical images, X-rays, CT scans, MRAs, and spot early signs of disease that might be extremely difficult for the human eye to catch. The AI can analyze thousands of images in the time it might take a doctor to review one, and in some studies, it has been shown to be remarkably accurate at catching early-stage cancers and other conditions. Doctors at institutions like Case Western Reserve University are working on AI that can look at CT scans and predict heart problems before they happen by learning to spot subtle patterns across thousands of patient scans. AI is also being used in drug discovery, analyzing molecules and predicting which ones might be effective treatments, dramatically speeding up a process that used to take many years. And AI tools are helping doctors manage the overwhelming administrative burden of healthcare, handling documentation, scheduling, and follow-up tasks so that clinicians can spend more time with patients. In everyday life, AI is behind so many of the experiences you probably take for granted. The recommendations on your streaming service, the navigation app that knows to reroute you before you hit traffic, the voice assistant on your phone, the spam filter that keeps junk out of your inbox, the autocomplete on your phone keyboard, real-time translation apps that let you communicate across language barriers. All of that is AI doing pattern matching on an enormous scale. AI is also transforming manufacturing and industry. Predictive maintenance systems analyze data from factory equipment and predict when something is going to break down before it fails, allowing companies to do repairs proactively instead of dealing with expensive, dangerous, unexpected failures. And AI is expanding accessibility in meaningful ways. Voice-to-text technology and text-to-speech, AI-powered communication tools for people with disabilities, real-time translation breaking down language barriers for people around the world, these are not just conveniences. For many people, these tools are life-changing. Now, I have been talking about how AI works from a fairly technical angle, even though I have tried to keep things plain and practical. But I want to bring it back around to something fundamental, because I think it is the most important thing to take away from this episode. When you use an AI tool, here's what is happening behind the scenes. The AI was exposed to enormous amounts of examples during training. It found patterns in those examples. Now it is applying those patterns to whatever you give it. When you ask a chatbot a question, it is not looking up the answer in a database. It is not reasoning through the problem the way you would. It is predicting, based on all the text it was trained on, what sequence of words is most likely to be a useful and relevant response to your input. That prediction can be remarkably good. It can also be wrong, sometimes confidently and convincingly wrong. Because the AI is not checking facts, it is predicting patterns. When a recommendation algorithm suggests a movie, it is comparing patterns in your viewing history to patterns in the viewing histories of millions of other people and predicting what you are likely to enjoy. It does not know you. It knows your data. When an AI reads a medical scan, it is comparing the patterns in that scan to patterns in thousands of scans it was trained on and making a prediction. That prediction can be very valuable input to a doctor's judgment, but a well-designed medical AI system is not replacing the doctor. It is giving the doctor another perspective, another set of pattern-matched observations to consider. Understanding this does not make AI less impressive. If anything, I think it makes it more impressive because what seemed like magic becomes something concrete and understandable. And when you understand how something works, you are in a much better position to use it well. Here is a quick summary of everything we covered today. AI works by learning patterns from large amounts of data and using those patterns to make predictions about new situations. Machine learning is the approach where AI learns those patterns rather than being explicitly programmed with rules. Neural networks are the architecture behind most modern AI, layered systems of connected nodes that process information and get progressively better at recognizing complex patterns. Deep learning refers to neural networks with many layers, which can handle very complex tasks. There are three main types of learning: supervised learning, where the AI trains on labeled examples; unsupervised learning, where it finds patterns in unlabeled data on its own; and reinforcement learning, where it learns through rewards and penalties. AI needs three ingredients: data, algorithms, and computing power. AI has real and important limitations. It reflects the biases in its training data, it struggles outside its training distribution, it lacks common sense reasoning, it can be a black box even to its creators, and it is not conscious or truly intelligent. And despite those limitations, AI is doing genuinely remarkable things in healthcare, everyday convenience, safety, accessibility, and many other fields. If you found this podcast useful, give us a like and follow us. Leave us your comments. If you want the full written guide, head over to AI4everyone.ai. The link will be in the show notes. And while you are there, subscribe to our free newsletter. Every week we cover one AI topic in plain English. No jargon, no hype, just practical stuff you can actually use. This episode was written by humans and AI. It was read by an AI voice. Thanks for listening to the Simple AI Guide. Join us for the next episode.